Hey, great to see you. Everything is all right? Cool. You're asking where am I? You see that building behind me? That's the office of our lead investor. In 30 minutes, I'll get inside of this building, we'll sign all the papers, and officially, our company will become a unicorn. Congrats. Yep, we made it. We made it, regardless of all the bumps. Almost 3 years, and our dreams come true. Cool. Yeah, congrats once again. Anyway, we still have 30 minutes, and I wanted to sync up with you on how we are going to scale our service across the globe. In particular, I'm interested in our core database, YugabyteDB. That's right. I know that you wanted to discuss this several weeks ago, but right now we have the best time. Why not? So, to remind ourselves, right now our YugabyteDB cluster is deployed in North America and serves user requests for folks from this region at extremely low latency. But our growing user base from Europe and Asia experiences much higher latencies. And their requests literally have to travel all the way from Hong Kong to our YugabyteDB nodes deployed in the United States. You're right. That's too much of an ask. And we have to deal with this somehow. Eventually, YugaBulls has to become a geo-distributed service that spans across continents and provides the same level of experience regardless of the user's whereabouts. And this particular lead investor gives us money just for that. They believe we can become the number one global service across the Americas, Europe, and Asia. And I believe it. Yep, you're right. We can do this. We've already done so much. So what are the options with YugabyteDB? Yeah, let's brainstorm. Generally, I think it's going to be straightforward. YugabyteDB can be deployed across geographies. And my thinking is that our short-term tactic is to attach the read replicas to the primary YugabyteDB cluster. Those replicas will be deployed in Europe and Asia, and they will improve the latency for reads tremendously, okay? So let's release this in prod next month, right? That should be easy. More about testing than coding. Yeah, I know that we tested something like that before. Let's do that. And as for the next move, we can deploy a geo-distributed YugabyteDB cluster that automatically places records in one of the geographies based on the value of a special geo column. Want an example? If that column is set to France, then the record will be stored in a group of nodes from Europe and not in Asia or in North America. And all the reads and writes for the record will go like into the European nodes. This way, Yugabyte will perform with low latency across the globe and will comply with regulatory requirements such as GDPR in Europe. Sounds exciting. Okay, but let's start with read replicas first. Okay, could you give a call to our lead architect and ask him to prepare the demo with replicas in Europe and APAC? And in the meantime, I'll get back in that building and I'll sign the papers. All right, deal. I'll call you back once the deal is closed. Bye bye now.
Alright, as you've just heard from the co-founder, YugaBulls is becoming a true global company. The service is expanding aggressively in remote locations such as Asia and Europe. And right now, the challenge for the company is to bring the same level of user experience across the globe, meaning that read and write latencies across the globe needs to be the same, regardless of where you live, whether in the United States, Canada, China, India, Singapore, France, Germany, or any other country on this planet. And also, as you remember, the short-term plan that the company is planning to implement within a month is to roll out in production read replica nodes that will be deployed in those distant locations. So what we've done so far. To remind you, we have the primary cluster deployed in the United States, and it spans multiple regions. And also I've added a read replica node. It's deployed in Taiwan, in Asia East region. So let's do this. I'm connected to a machine, virtual machine that is deployed in the same region. So that's the first connection to that machine from Taiwan region, and that's the same connection. So what do I want to demonstrate you first? Let's say that you are launching a backend instance of YugaBulls in Azure, but right now you still are connecting to a node deployed in the primary cluster. So in this case, I'm opening a connection with PSQL, and that connection will be opened with a node that is deployed in the US Central 1 zone. So my expectation is that whenever I will be sending requests from this connection, the latency will be high. Okay, connecting to this node. Let's enable timing so that we can see the total time it takes to execute a query. And that's the query that we can run. So this query returns the most popular symbols or the most popular stocks that are being purchased right now in real time by different traders. So if you keep executing this query, you will see that on average it takes around a second and a half to complete it. Because right now, again, that's my connection. I'm connected to a virtual machine that is deployed in Azure, and from that machine, I'm connected to the primary cluster that is in the United States, and all of these requests have to go from Azure to the United States, so that takes time. And also we know that right now we have a read replica node. So let's connect to that read replica. Again, I will open a connection with PSQL, but this time PSQL will be connecting to my read replica node. So the connection will be local within the same region. My read replica is in Taiwan, and my virtual machine that opens this connection is also in Taiwan. So my expectation is that the latency for the same queries will be significantly better. Okay, let's open this connection and let's execute the same query. The query completed, but forgive me, I forgot to enable the timing. Let's fix it and execute the same query once again. So you see that surprisingly, it takes even more time to execute the same query from this read replica node. So actually what's happening right now, even though I'm connected through a read replica node that is located in the same region with my virtual machine instance, I have not requested, I have not allowed to use this read replica's data. And what happens right now is that, yes, I'm connected to the replica node, I'm executing this query, but this query is being forwarded by the replica node to the primary cluster to the United States. That's why this latency is even worse than it was before. Then the obvious question is, how do we improve the latency? How do we request our SQL connections from PSQL or from their applications to use the data located on the read replica node? It's easy. Before you execute any query, you need to enable two parameters. First, you need to enable session characteristics and set them to the transaction read-only. And second of all, you need to enable this flag. You need to set YugaByte read from followers flag to true. Once you do this, you will be able to read the local data that is available on your read replica node. Let's do this. Done. And now if you execute the same query, you will see that the performance is much better, right? To remind you how much time it was taking to execute the same query, but through the primary node. Again, that's the instance that is in Azure, and that instance is connected right now to the primary node cluster. It takes 1.5 seconds, but again, from the same machine, but the local connection to the read replica, it takes 300 milliseconds, like 3 times better. So that's the read replica in action. And if you keep running this query, you will see that the data actually keeps changing, because all the updates are happening and processed on the primary nodes in the United States, and then the cluster asynchronously sends all of those updates to my read replica in Taiwan, in Asia. Another important thing to remember is that read replica nodes in YugabyteDB are intelligent. What do I mean? Whenever your users from Azure need to buy any stocks or to do any write or update operations in your cluster, then you can reuse the same connection through read replica. You don't need to open a separate connection to the primary cluster from Azure if you need to do any updates. Just send all of the updates through your read replica connection endpoint, and the read replica node will forward all of those updates automatically to the primary cluster for you. Sounds nice, right? Let's see how it works in practice. To do that, let's try to update one of the records. So for instance, let's see what's the current value for this record. Okay, you can see that's like someone purchased 500 stocks of Google, and let's try to update it. Let's, for instance, set their order quantity from like 500 to 1000. However, when you execute this query for the first time from the read replica, you will see this exception, which said that updates are not allowed in the read-only transaction mode. That happens because before we enabled this parameter for the read replica. And again, it's easy, like whenever you need to send updates through the read replica connection, just allow to do that. Enable transaction read write session characteristics. Do this. And then you could repeat the same query. Update succeeded, no any issues. Let's read this record back. Yep, it updated, and we see the final value on the replica side. And what if I wanna check the same value but on the primary cluster? Again, that's my connection to the primary cluster. If I run this query, the same value. It means that from my connection was open to the read replica node, and I sent an update operation through the replica node, and the replica node automatically forwarded it for me to the primary cluster. Excellent. So that's it. That's how easily YugaBulls as a company can expand to remote locations. What else when it comes to, let's say, geo-distributed applications and multi-region deployments? As the co-founder mentioned in the beginning, their long-term plan is to use a geo-partitioned cluster. So generally speaking, check this article where we review other deployment options for the cases when you need to improve the latency and performance across the globe, regardless of the user's location. All right, that's it. That's all when it comes to this series. Let's wish luck to YugaBulls, because the company experienced great success and they still have a lot to do in their plans. But let's try to recap, because the overall goal of the series was to answer on the primary question: why YugabyteDB? Why do we need and what do we use YugabyteDB for? And the short answer is YugabyteDB is a geo-distributed SQL database that scales across geographies and can improve the latencies for both reads and writes. Second of all, YugabyteDB is fault-tolerant database. You can easily withstand all sorts of possible outages, including natural and human-made incidents. And finally, YugabyteDB is a Postgres-compliant database. It's built on the PostgreSQL source code, which means that you can easily migrate your existing applications from Postgres to YugabyteDB or build new ones and reuse the ecosystem of drivers, tools, extensions, and different frameworks that were originally created for Postgres, but also can be used for YugabyteDB. All right, so what's next? Don't forget to ring the bell and subscribe to this channel to get notified about new technical content that we are preparing just for you. See you soon. Bye-bye.